Okay. Guys. Let's do this. X1, Y1. X2, Y2. M equals. Please stop talking. Y2 minus Y1. Please stop talking. X2 minus X1. And two negatives right next to each other make plus, so that's 9. Two negatives next to each other make plus, so that's negative 16. Is that it? I think that might be it. I can't reduce that, right? Nothing goes into 9 and 16. Anyone? No? All right. Okay. I think that's it. It's a little bit of a weird slope. That's fine. Yeah, but you're not wrong, but that would be even more complicated than what it is now. The man is correct, but I'm not going to do that because I want it to be a reduced fraction. Okay. All right, now number 4. Now remember, I told you guys these are all weird ones down here. And this one is missing the y-intercept, so I put +0 on the end. So the slope is -3/2. And b is 0. Okay, so that means I start at 0 on the y-axis, up and down, and then down 3, right 2, down 3, right 2, up 3, back 2, up 3, back 2. Okay, any questions about number 2 or 4? Anything, number 2 or 4? Good? Okay, next thing I need you guys to do is make sure that each person in your group has one of the bright pink Post-it notes. I put bright pink Post-it notes on your tables, and you need to like separate them apart and make sure that one person in each group has one. We're just going to use it for the right angle. So today we're going to talk about slopes of parallel and perpendicular things. And you do not need your packet anymore today. You can put your packet away. Okay. So the first half of chapter 3 is reflections, rotations, and translations, which you saw we did the reflection stuff on Friday, which was easy and review and wonderful. And today we're going to take rotations as a topic and talk about them in terms of algebra. It's a little bit different than something you just draw. We are going to draw things today, but we're actually going to draw lines and we're going to use our post-it note for the right angle because I need to make sure you guys understand two vocab words today. The first is parallel. So parallel things are like this, right? Parallel. And then perpendicular is like this at 90 degrees. So parallel, perpendicular. Those are the two words you need to know today to understand what we're doing. Okay, so number 25 is kind of a review problem from Friday. So actually, first thing I want to do is talk about what we're doing today. We're doing 3 problems in from the CPM book, 25, 27, and 29. And then notes on slopes of parallel and perpendicular after that. And the homework is 32 to 37. And here's my joke. So it's got a guy and it's midnight and his homework's life is almost dead and he just needs to finish him, but he doesn't want it. Does it make sense? Like the life, no. Like when you play a video game and you're killing something, you know, and it's almost dead, it's all red. No. No? You have no idea. Well, that's good. That means you don't spend too much time playing video games. Do you ever not want to finish your homework at midnight, though? Do you ever not want to finish your homework at midnight? You guys all go to bed early? I mean, I wouldn't do that as a general rule. Okay. Can you guys take a look at this picture here? So let me zoom it in for you. Let me zoom it out slightly. Okay. So this is just like number 6 that we did on Friday. At right, triangle PQR was reflected across line L to form triangle P prime, Q prime, R prime. Describe the relationship of the original triangle and its image to the line of reflection. So there's some really important things you need to know here. First, can you identify the original triangle and the new triangle? By looking at them, can you tell which one was the original and which one is the new? Okay, the original one is the regular letters, and the new one has the little primes on there. And the primes are basically apostrophes, but in math we call it prime, and it means changed. Okay, so the first thing we're going to say, we have 3 bullet points. Why did I draw I don't know. I don't know why. That's really, it's fine. It's fine. Okay, so If you look at a picture like this, can you identify which one's the original and which one's the new?
Yeah.
Okay, perfect. That was really what I meant to get at. Yes.
If a square is being reflected, would it be like another letter?
A square? Yeah. And you would not put the triangle in front of it. You would just say A, B, C, D, and then A prime, B prime, C prime, D prime. Excellent question. I love it. Okay. Now, what else can you say about reflections? Do you guys remember the shortcut I taught you on how to not use tracing paper? Tilt your head. What was the shortcut that I used to get one from one to the other without using tracing paper when it's tilted? Yes. Use it Perfect. Okay, so I'm going to translate that. That's kind of a bad word to use right now. We're talking about translations, but anyway, I'm going to take that and put it into CPM words. They want us to say that the old triangle and the new triangle are the same distance away from the line of reflection. Does that make sense to you guys? The old triangle and the new triangle are the same distance from the line of reflection. Can you guys tell from counting the boxes? Like, hopefully. Okay, and the last bullet point I put there, I want you guys to know a little bit of vocab that you might hear. You don't have it in the CPM book that much, but just in case at some point we do a Kahoot or something, there's another type of vocab. Sometimes the original is called the pre-image, and sometimes the new is called the image. Just in case you see that vocab come up anywhere, I want you to know original is pre-image and the new is the image. It won't be very much in your CPM book, but you might see it out in the world. Okay, so now we're going to start to work on rotations, but we're going to work on them first with algebra. So I'm going to scroll this down a little bit. And what I want you guys to do is I want you to draw me a slope of 1 down here in this white space. So I'm going to draw a slope of 1. I'm just going to pick a point somewhere. And do you guys know what to do with the slope of 1? Up 1 over 1. Okay, do you guys have any questions about what I drew? So I drew just a random line that has a slope of 1. And you can see the slope triangle and how the slope triangle will look with a slope of 1. Okay, Now I'm going to draw a line that is parallel to this line. A line that is parallel to this line might be here. I really didn't want that to go as far up as it did. Cut that off right there. Are you guys okay with that vocab parallel right there? Okay, what is the slope of my parallel line? What? Okay, now what I want you to do is take that Post-it note that I gave you. So first of all, do you guys know that this is a translation? I just shifted it up. You guys know shift, like slide? Okay, now we're gonna rotate. So take your Post-it note and pick one of the points on your one of your lines and make a 90-degree angle. We're gonna rotate it 90 degrees. And we can be pretty sure that whatever machine chopped these Post-it notes did a pretty good job of making it 90. You can trace along the edge of your Post-it note. I'm going to do dots because I'm a nerd. Make sure to put that little right angle in there. What's the slope of my perpendicular line? Mm-hmm. Okay, do you have a guess as to how to find the slope of a perpendicular line? Do you have a guess as to find the slope of a parallel line? Yeah. Yep. But what about perpendicular? Still not sure? Okay, that's fine. Let's do another one. Okay, so come down here. Actually, don't do that. That's a bad idea. I just realized the slope was negative. Okay, start up here and go down 2/1. Make a slope of -2. Okay, here's my question. Do we need to draw a parallel line to this to figure out what the slope would be? No, we can assume that because they're parallel, they're going to have the same slope. I don't need to draw a new picture. I would like to, however, draw a picture of a line perpendicular to see what happens because we haven't really made a guess there yet. So take your Post-it note. Line it up. Didn't really need to go that far. Okay, what do you notice about the heights and bases of the slope triangle? Yeah, Jalen. They switch. Okay, what do we call it when fractions switch? What's the vocab word, the proper vocab word for when fractions switch? Reciprocal. Beautiful job. Okay, so this to this is called an opposite reciprocal. Let's talk about those two words. Very important. Opposite reciprocal. Opposite means that you change the sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. And then reciprocal means the fraction flips over. So change the sign, flip the fraction. Did you guys ever learn that? Maybe you did. Hold on to the question. You ever learn that you could say reciprocal to remind yourself of the word reciprocal? No, you didn't learn that one. That's just a Mrs. Talbot special. Okay. So let's not draw this one. We're going to use all the stuff we learned here to figure out what the parallel slope would be and what the perpendicular slope would be. Okay, if I have a slope of 3/4, every parallel line to that is also going to have a slope of 3/4. Is that okay with everybody? Because they're parallel, same. Okay, now, perpendicular means 90 degrees, it's rotated. What is the opposite reciprocal of this? Yes, Landon. It's -4/3. Yes, 90 degrees specifically. And if you want to put that right there, that is a rotation, 90 degrees. You flip the fraction and switch the sign every time. Flip the fraction, switch the sign. Okay. Now, how do we use this? We use this in problems like this. So we have one more problem and then the notes and then we're done. Do you want me to zoom in? The good news is we're done drawing. I don't know if that's good news or bad news. Not right now. As soon as I'm done. Okay. I'll go quickly. Can you guys knock it off, please? Whatever that is you're doing, just chill, please. Okay, so y equals mx plus b. M equals b equals. Okay, so we have to pause. This one is telling us perpendicular. And the symbol for perpendicular, by the way, if you're too lazy to write out the word perpendicular, is that upside down T. You can always write that in place of the word perpendicular. And I'm actually going to put it in front of the slope. So I want to remind myself that I want the perpendicular slope. Okay, the slope is -2/5. What would the perpendicular slope be? Jalen? Yeah, so flip and make it positive. Okay, now this problem is special. They gave you B. Can you tell what B is? Nope. -3. Please stop yelling stuff. Thank you. Okay, now somebody said 6, and you're not wrong, but it's telling you perpendicular to this line through this point. So you want to get your B from here, and it's not this line, it's perpendicular to this line through this point. So all we have to do is write y equals 5/2x minus 3. Okay, now this problem says parallel, so I'm going to use the symbol for parallel, which is 2 straight up and down lines. It looks like an 11. So you have to be careful. Don't think of it as an 11. When it says parallel, the slope is already given to you, 3/2. And you want to use the b that they give you in the problem. 7. Y equals 3/2x plus 7. Easy. Okay, now we're going to do the notes. And the notes are going to be exactly like this, except for they're not going to give you B. They're going to give you a point. So you actually have to do some maths. Oh no. How dare you ask us to do maths, Mrs. Talbot, in the maths class? Do you know that they call it maths everywhere else in the world except for here? Did you not hear anything I said up here? Awesome. I said that when it's perpendicular, the slope is the opposite reciprocal. Yeah. Can you knock it off? Please, just write the thing, do the stuff. Okay, so we're gonna write some stuff right here. Parallel lines. Okay. Parallel lines, they have the same slope, so the same M, but different y-intercept. What that means is you don't want to use the y-intercept from the problem, you want to use the point from the problem. Okay, so this one says parallel. The first thing I'm going to do is note that this problem says parallel. And so over here, I'm going to write parallel slope x equals y equals. Parallel slope x equals y equals. First, I'm going to get the point, which is my x and y. And then I'm going to get my slope from over here, which is going to be -5. I don't want that b because it says they have the same slope, but different b. So I need to find my b. And then you just do the same thing you did in chapter 2. Do you have any questions about where I got stuff from? Where I got the things and where I plugged them in and where they went? Okay, we have one more to do, it's perpendicular, and then we're done. It's gonna be great. Okay, so let's write our definition. Perpendicular lines have opposite reciprocal slopes and different y-intercepts. Perpendicular lines have opposite reciprocal slopes and different y-intercepts. And if you want to, if you need to, if this helps you, you can write yourself a little bit of directions. Opposite reciprocal means change the sign and flip. first thing I'm going to do is notice that it says perpendicular here. And then over here, I'm going to write perpendicular slope, x equals y equals. I'm going to get x and y first from the point that it gave me. And then I have to take 2 and get the opposite reciprocal. Okay, how do I flip something when it's a whole number? Okay, so over here, if you want to, you can go 2/1, and then the new slope will be -1/2. And I'm writing that little arrow to show like my 90-degree rotation there. So that's how I find the opposite reciprocal. So this will be -1/2. Y equals mx plus b. One equals -1/2 times -1 plus b. If you want to, you can cross that out if it is going to get in the way of the rest of your problem. So you don't think that that's b. 1 equals +1/2 plus b -1/2 from both sides. Do you guys know what 1 minus 1/2 is? 1/2. I think about it in terms of toast. I have 1 piece of toast and I eat a half a piece of toast. That means I have a half a piece of toast left. I like toast math. Okay, any questions about where I put numbers, where I got numbers, what I did with them? Good, yes? Are you not, you're stretching? Okay, sorry. Okay, keep stretching. Okay, you guys all know how to do opposite reciprocal? Okay, what's the opposite reciprocal of 2/5?
-5.
Okay, what's the opposite reciprocal of 1/7?
7. -7.
-7/1, which is -7, yeah. You guys got it? Okay. Okay. You have 9 minutes to work on your homework.